up to 15 kilonewton forces, but we charged it into hydrogen environment for 24 hours. Now the brittleness increases. How much? It how much? So it decreases the maximum withheld force to 15 kilonewton to 6 kilonewton. That much brittleness it decreases, because see, to break this you have to give a much larger force, but to break this you have to give a much smaller force. So this is called brittle. That's why this is called brittle. You need very less force to break. This material is taking very less force to break. So this material is going to be brittle. This material is going to increasing the brittle nature, and you can see the cracking. Fracture pattern. This is a brittle fracture, because if you break glass, you can see that kind of fracture. Not this kind of fracture you can see in your glass. No. So this is called ductile, and this is called brittle. This is called ductile fracture, and this is called also brittle fracture.
But mostly brittleness occurs in metals only.
No, ductileness occurs in metal. Brittle means it will break
On
easily.
heated metals only brittleness occurs.
Brittleness means it will break easily. That is, it is hard, but it will break.
Yeah.
That is called brittle. And ductility means it will bend and it will withhold your forces. Elasticity is a different thing. If I bend this will not come to your normal phase easily. You have to bend it again.
Yeah.
And elasticity is something, if you
You
stretch it,
can stretch it to normal.
if you can stretch it, you leave it, it will come to
Normal
normal.
state.
Like your rubber band. Like this. This is elastic. That's why this is also called elastic bands. There are some, that is some different properties. So I have now addressed you the problem. Now what? I have to give you the solution. Now you are not going home with the problem. You have to take the solution also. What we do, we can paint it with something that will not absorb the hydrogen, you can say, because it is a hydrogen tank. From inside we can paint, but the hydrogen will be in very much high pressure, because you are
Bombarded.
no that you have LPG gases in your home. Everybody have. So LPG are gases. So they pressurize the gases into the tank to form liquid. There are high pressure of gases. Actually, that is not liquid. If you get out, it will be gas. So same thing will happen. You have to pressurize the gases. After you pressurize, the inner painting wall will be gone off, easily peel off. So we can't do that. Now we can do one thing. We can electroplate it. We can electrochemically coat it with different materials, which can prevent the hydrogen to get absorbed by the metal, and also prevent the metallic corrosion, atmospheric corrosion. There two samples are bought at the same time. This is kept in the atmosphere, and this we coated. This thing also repels hydrogen. We have to cut it in small pieces, and we have to check. This thing also repels hydrogen itself, and this thing also protects the material from rust. So the material we used here, we based on nickel and zinc alloys. Alloys, two material used in a different like
Proportions.
your proportions, like that, whatever you are required. We have different proportions of nickel and zinc alloys. We use to coat it using electroplating coating. Then we are using it. So we are charging the hydrogen here, but the hydrogen will not get inside the metal. You can't see that. But if you check that in the this test machine, we can't take the machine here. This is a very like a costly machine and sophisticated machine. So we will cut the specimen in like 18 millimeter, 18 diameter and 0.5 thickness, and we can test it in the machine. It will see you. It can show you there's brittleness or ductileness. There is another that on one study. We can't just do one study and report. We have to do another study to support that theory. So we do another test called slow strain rate test, SSRT. Okay. So what happens? There is a the specimen is this size, 0.5 thickness, 8 diameter. The specimen will be 8 diameter, but the thickness will be 10 centimeter or whatever the machine required. So there is two clamp attached to the machine, and it will pull your specimen. That is pushing, and this here is pushing, pulling, and in the meantime, there is hydrogen getting generated, and hydrogen charging also happens. So you can see in real time how much hydrogen is penetrated or how the hydrogen is affecting your brittleness or ductility in that curve. Okay, there is another experiment we can do, hydrogen electrochemical hydrogen permeation. So there is two chambers like this. There are two chambers like this, and inside there is your metal. There is your metal. One side your this kind of reaction will happen, hydrogen will be generated, and one side there will be hydrogen sensation. It will be galvanostatic current and there will be potential static current. So what happens? This side is hydrogen is getting generated, and after that hydrogen is diffused in the metal. Then from this side it will come at one certain point. So that much, yeah, we will check like this side. So that's how we can say this metal or the thickness will be increased or decreased after coating or after coating 3-4 layers, and how much hydrogen is permeated. So like that, the one experiment we do. Basically, we go do this kind of experiments here, and this is the all setup. Not all. This is one setup. There is one setup you can take out, and this setup we are making the cell which is in the workshop right now. If you go to workshop, then they will display it. They didn't give it to us because they will show it. They made it. We designed it, but they made it. So that's all my. Any questions you have?